Square?
Yeah, it's a square root, so you unsquare a square root by squaring both sides. If I square a square root, this says that 3t plus 4 equals 4. 3t equals, well, subtract 4, 0. T equals 0 divided by 3. What's 0 divided by 3? 0. If in doubt, take your calculator out and calculate it. Now, there's a couple of things I want to remind you in terms of review, and that's this, is that if I'm dealing with the square root of 3t plus 4, 3t plus 4 has a domain issue. And that is because I can't take the square root of a negative number because it's not real. It is imaginary, so it does exist as an imaginary number, but not a real number. Most of the time we're going to be dealing with real numbers, which means that what's under the radical, which is called, by the way, the radicand, must be greater than or equal to 0. Which says that 3t plus 4 must be greater than or equal to 0. 3t must be greater than or equal to negative 4, or t is greater than or equal to negative 4/3. T can be negative. What can't be is 3t plus 4. So that would be the domain. I got 0. Is 0 bigger than negative 4/3? Yeah. And that would be a reason why you need to check your answer. Another thing that I wanted to remind you of is, why do we square both sides? Is that 3t plus 4 is the same as 3t plus 4 to what power? 1/2. Square roots are halves. Because the index is 2. So that when I take 3t plus 4 to the 1/2, because that's the same as the square root, and then I square it, the property of exponents would multiply those two exponents. I end up with 3t plus 4 to the 2 over 2, which is just 3t plus 4, right? That's why you square a square root. And that's why you would cube a cube root. Because when you raise it to the power, it kills the denominator of the fraction, which is what a radical is. It's a fractional exponent. For those of you going into 212, you're going to be doing a lot of fractional exponent stuff. And in the calculus, engineering calculus, same way. Now, this guy's a little different in that I can't square him as he stands. This is more than one term. And more than one term means he's got an inner-outer product. So he's agali. So the first step to doing a problem like this is to isolate the radical, or get the radical alone. Then when you square him, it kills him off. So I'm going to subtract 2 from both sides, so that the square root of 12 minus 2x equals x minus 2. Now I've got a square root. See, there's my left-hand side, there's my right-hand side. The square root is by himself, so when I square him, he goes away. Now, this is really x minus 2 times x minus 2. So this is x squared minus 4x plus 4. I have a quadratic. So quadratics, we want to bring everything to one side, 0 on the other. Since x squared is positive on this side, I'm going to move everything to the right-hand side. X squared, add 2x, subtract 12, so add 2x, subtract 12, and then you hope it factors, which it will at this stage, because if it didn't, what would you use? Quadratic formula. So 0 is, and this is going to be x minus 4, x plus 2, so that x is 4, x is negative 2, and then what I have to do is I need to check my answers. And I go back to the original, which is 2 plus the square root of 12 minus 2x should equal x. And you say, well, why do you go back to the original? Well, mainly because of the fact that if I made a mistake in moving like that 2 over or squaring it or something, right, I have the correct answer to the problem I worked, but it wasn't the original problem. And many times we do that. We get the correct answer to the problem we worked, but we made an error and it wasn't the original problem. So I go back to the original. And so that if x equals 4, is it true that 2 plus the square root of 12 plus 2, or 12 minus 2 times 2, is that equal to x, which is 4? Well, this is 2 plus the square root of 12 minus 4. 12 minus 4 is, oh, this should be a 4. Okay. 12 minus 8 is 4. There's my 4, which is 2 plus 2. Well, 2 plus 2 is 4, and it checks. Yippee! Well, suppose x equals negative 2. Is it true that 2 plus the square root of 12 minus 2 times minus 2, is that equal to minus 2? Well, this is 12 plus 4 is 16. So this is 2 plus the square root of 16, which is 2 plus 4, which is 8. And you notice they are not equal. So if I go back up, x equal negative 2 is not an answer. So my answer is just x equal 4. Good timing.